So today I'm going to be going over some, I would say, performance tuning work in PySpark. It's something that I am using a smaller data set here because I know that there's a cost component to you guys using Databricks. But I wanted to be conscious of that you would have to be paying for this. But I wanted to also still show you some of the different functions that you would use when trying to do performance tuning. I want to back up to the first class and show you two slides just to remind you of a couple things. So we go here. So I want to remind you of something called transformations versus actions. So this is going to come up throughout. I'm going to be talking about transformations versus actions throughout. Transformations occur when you submit something to Spark, but you don't actually call that. So you're not actually, say, printing or using a display or calling and using that result in some way. When you are doing a transformation, it basically creates a queue. And you can think of it as a SQL query almost to some degree, and then it keeps adding to it over time and has those different actions. So when you actually hit display or show or return a result, Spark goes back and makes multiple plans, decides which plan is the best and most efficient plan to use, and then it goes with that plan and then runs through your entire code base. It does that so that if you don't know the most efficient way to do something, it decides for you. So that queue just keeps, that list of functions keeps adding to that. The more transformations you run, joins or transformations, select or filters. Actions are something like showing a count or using the display function or the show function. and then it's got to collect it together and do the order by in one area. So when we do this, we have to take that into account. So a select function, that's easy. It can take those information from the different partitions and it can just return that information. But when we do something that requires something from all the different partitions, that requires Databricks to then shuffle and move your data around, and that is extremely expensive computationally. So we always want to keep that in mind and keep that to a minimum. One of the great ways to have that not become a problem when you're working with real big data, in this case, the broadcast join is actually not going to run. But a broadcast join, you can imagine sometimes when you have a really big data set, and instead of having and adding one column for something that has 4 categories, they'll put it as a lookup table. And then you'll actually merge that in with your entire data set as to not keep all that information in one table. That happens a lot at work. And if you have a really small table that you're joining with a really big table, that can be a huge problem if you don't do something called a broadcast join. The broadcast join takes your smaller data set and it makes a copy of it and puts it on every partition of your cluster so that it doesn't have to move data around in order to take that small data frame and join it with the big one, because each cluster has its own copy of it. So that is what a broadcast join does. We've talked about the plans already. So what you do here, and you can see the broadcast tech migration. This is just in the middle of a normal join that you would do in PySpark. This you hint, they call it a hint at a broadcast join here. So you just wrap whatever data frame you want to broadcast or copy to every partition, wrap that in a broadcast with parentheses around it, and it will prompt Spark to check if the broadcast join is necessary in this use case. We take that, it hints that we should use a broadcast join, and if you don't need it, Spark will not use it, but it prompts it to check. And then when you run that, it will join it, and you don't even see anything different on your end. It'll just happen a lot more quickly, and you will prevent what we saw right here with the uneven partitioning. That actually keeps it more even over your partitions when you join with something called a broadcast join. And therefore, Spark doesn't need to shuffle your data across multiple partitions. It just has that small table there for you. The next thing, these are things that you want to use with caution. I will say that straight up, but it is, we talked about the plan and how it reruns through all your code every time you collect something. Well, when you've done 10 joins, 20 aggregations, and you run your code, that becomes a problem when it has to run through those joins over and over and over again and go through. So what I showed here, and I have actually 3 different choices. All of them do slightly different things. You wouldn't run all 3. I accidentally kept one uncommented, so that's what's showing here. So the first choice, and this will be, I would say, your most likely choice. When you have a really big data set, you've done a lot of operations, and you don't want to have to do them again. Persist is often your best option. What that does, it takes your data and pulls it into memory as well as disk. So by default, it will put data into memory until memory fills up, and then it'll put it in disk. Or you can actually take it and say, I want it only to go in memory, or I only want it to go in disk, so that you can keep that record of the data frame without having to go through all of the joins and aggregations you did. So this is a good representation. By the way, this website is excellent. If you're looking for like debugging tips or want to know how to do something, Spark by Examples is really good. I use it pretty frequently. Highly recommend that. So these are the options that you would have. So with persist, you can use memory only. You can also use memory and disk, and then there's a lot of options here. Also making copies in case one of your nodes crashes, you would have another copy somewhere else. So that is what persist allows you to do. Cache, by default, puts everything in memory. This one you want to be cautious with. This one you want to be even more cautious with. So basically, if you have a 10 gigabyte data set and you're doing a lot of operations on them, if the data set cannot fit in memory, what that will do will crash your cluster. It'll be gone. That actually happened to someone on my team today. He was using R on here, so he was working all on the master node. And I came in, and I'm just going to show this in a new tab. And he didn't really know what was going on. So I came into his cluster, and I saw that only one node was running. So you can see driver logs here. So if something goes wrong, it'll actually tell you what it did. But the really awesome feature that I use a lot is metrics. So what this allows you to do, and I keep it open all day, especially when I'm doing really big data sets, and I've been doing a lot of that lately. I keep this open. Right here, we can see I only have one node running because I don't need more with this data size. So you can see here how much is in use. I believe that's the blue. You have green, which is what was cached. We just talked about caching. And then we have buffer, free. So the yellow is free. You'll also see a server load distribution over there. As we have more nodes in our data set, this will be put into grids here. And then if the cluster load is getting really high, it'll turn orange. And then right before it's about to crash, it'll turn red. So if you will see down here, if your cluster crashes, there won't be anything. And basically your functions will sit and they won't move. And they'll just keep trying to run, and that's when you would come in here. And when you're going through and doing big data calculations, if you see it, I call it hitting the ceiling. I don't know what the technical term is for that. But if you see that very little of your free space is open, that means that you probably have to shut down your cluster and reprovision it and make it bigger. My rule of thumb is to always keep, in general, I try to, even if it is a little more expensive, it's going to take more money for you to have to rerun and do that than it would to just use a larger cluster to start. And Databricks auto scales, so that helps as well. So that's what cache does, puts it into memory. And that you saw a spike. That's probably when I used cache was what happened there. And finally, collect is it puts everything into memory on your driver node. So if you have a worker node and a driver node, it puts it all into memory on that area. The only time I ever use this is when I have a result and I want to pull out an integer from a data frame. It's often easier to use if you collect it and put it to an object. Like that's literally the only thing I ever use it for. So unless it's a 4-row data frame, I really don't use this much because it is very likely to crash your cluster. So right now, I have partitions on my data. I might actually only have one in this use case. So it's saying 200, which is actually surprising. So it is partitioning my data. And sometimes when you use a really large number of partitions, that can happen after many joins, many aggregations going through. You can end up with too many, or you can have too little as well. Too little is having too much of a load on your cluster. Hey guys, are we having trouble with my internet still?
I haven't had any trouble from your side.
All right. Okay, good. Thanks. So we have this repartitioning, and if you have too many partitions, in a lot of cases, you want to take them and put them in a smaller number. So in this case, it will repartition and give me 3 partitions instead of the 200 that I have listed there. In this case, it's not working normally because I actually don't have a distributed cluster. I'm working on only one node. So that's what it would do. There's also an option called coalesce that allows you to, you should use that one in general when you want to decrease the number of partitions. And if you want to increase, it doesn't allow you to do that. So coalesce won't shuffle your data, so it'll happen a lot quicker. And finally, you can also repartition on a regularly used data set. So in this case, in this data set, we have our LinkedIn data set. We're often using country name as the basis of all of our analytics. So we're grouping by country name a lot. So if we wanted to make it go more quickly, since we're aggregating by this already in many cases, you could actually repartition by country name, which will also make everything go a lot faster. All right. So in this case, it coalesces it and makes it to 2 partitions, and that's how you would use coalesce. In general, when you use these functions, you just tack them on to the end of the entire string of functions. And that's how you would use it at the very end. So what this would do, it would mean that all of these joins and aggregations that I've done further upstream, it doesn't need to run through them again every time I collect. So it basically starts right where I cached it to memory, and it moves on to my new functions. All right. So one of the great things about Databricks, even more so than other platforms for using Spark, is that it allows you to use multiple languages. And really any platform for Spark, using SQL is easy, even if you're using a Python notebook. But I'm going to talk about first how you would use SQL, even though you're using PySpark in the same notebook. And then I'm going to show you how to use R, because that's something that my team in particular needs. They have R code already written out that they want to then pipe into PySpark code, because they don't want to rerun it. So we just have a really big master node that they run this base R code on, and then it goes straight into a PySpark notebook. But you may want to use SQL. Data engineers are going to be a lot more comfortable with using SQL instead of PySpark. So that SQL code, what you would do first is you would take and create or replace a temp view. So I'm creating, with industry growth in this case, a temporary table called SQL table. And in general, when you switch languages, you always have to convert the data frame from the type from one language to the type in another language. So that's like the pre-step that you have to do before going through the exercise of using SQL. So that's what this does here. It says it creates a temporary table called SQL table. And then here I'm able to then take my my SQL table. You can see you use it like a from statement, like you normally would in SQL. And I'm selecting country name, WB region, WB income from SQL table. And I display it here, and it has subsetted those columns using SQL instead of PySpark or Python.
You said it was the create or replace temp view that's creating the SQL version of your data frame for you?
Yes, exactly.
Okay.
Yeah, and it looks like that for other languages as well. So if you guys, I don't know if you were in one of my first classes, so you can use several flavors of SQL, and Databricks is the only one where you can use them in the same notebook. But you can use Java, Scala, Python, SQL, and R. You could potentially use them all within this notebook. But this prepares it. SQL you can use very easily just inside of the actual Python function as well. Are there any questions about this or repartitioning or coalescing? Okay, sounds good. So we created that temporary table. We used our SQL. We displayed it here. This is another example of a way that you can use SQL. In this case, you do not have to create a temporary table because all of this is done within a single Python function. So we have our skill penetration data set. There is a specific SQL function that allows you to just select columns using SQL syntax. And this is, if you're more used to that language, it's going to be easier to use. And you can also do something like this. You see here that I have a proportion in this case, and I wanted to change it to a percent. So I took my skill group penetration percent times 100, and I selected that as a new column called skill group penetration percent. Since select expression is a Python function, you don't have to do the create or replace temp view that you did up here. So that's really helpful. I will say one thing, SQL is really easy to use. We at work have been having trouble with the next thing I'm going to show you for sure. Oh, after this, I will show it after this. So one thing that you will find, so up at the very top of my notebook, I use something called infer schema equals true. Unless you're using a really big data set, I often use infer schema. It does a really good job of guessing the schema of my different columns, much better than most languages I've used actually. So it does a good job with that, but if you have really big data sets, there is a way to actually specify the schema here when you read it in. But sometimes it's going to get the schema wrong. There might be a string inside of your numeric column that makes it actually go and become a string when you wanted it to be numeric. When that happens, this becomes in handy. This is going to look very much like SQL. This is called SparkSQL, so it has a similar flavor to it. So as we've gone over in other classes, with column is how you create any new column, or you can overwrite the old one, which is what we're doing here. So in this case, I want to take skill group penetration percent and change it to an integer type. So real quickly, I'm going to take my select SQL data frame, run that again just so it updates. Take our select SQL data frame. And D types tells me my data types. So right now we have a double for the skill group penetration percent, which means it's numeric with decimals. That in this case, I'm showing you how to actually change that to an integer, so it would automatically round it for you. So we're overwriting the old variable, the skill group penetration percent, and then we're using the data frame here, you have to list it both in the front and in front of your variable here, or you can use COL, the call function, and wrap it around your variable name. And then you use the cast function, just like you would in SQL, and then do integer type to specify that you want an integer. You always have to read in or install this particular package. I always forget to do it. Or you can do like a SparkSQL and basically import the entire package, and then you won't run into this problem. But now that I run that, we can see skill group penetration percent is now an integer instead of a double. The use case that I use most often here, every PySpark modeling function, so if you're running a logistic regression, linear regression, it requires everything to be double type. So even like if it's a 0, 1 variable, it has to be double. So there are times when I've gone through, there are ways to build that into the model and the pipeline itself. But in general, there are use cases that come up where I have to change them like single columns before modeling. So I've talked a little bit about mixing languages in Databricks. So this I definitely have had a little bit of trouble with, just trying to get my teammates in and using R. The struggle isn't really the using of R. The struggle is more with getting this part right. So we've been having some trouble getting the registering of the temp tables to work correctly and getting them in the right language when we're switching between SQL, Python, and R in the same notebook. It just gets a little bit difficult. But we do a very similar thing to what I showed up above, and we take our migration country industry and we register a temp table. I'm going to be using this table in R in the next cell. So we create that migration country _R. We then, after we create the temp table, you're going to see that SQL function come up again. This is the easiest way to do it. There are other ways, there are multiple ways, but this was the easiest one for me. I don't know how many of you are R users, but this is R syntax. So it takes that table with the SQL function, selects everything from that table, and then I wrapped R functions around that table. As data frame, takes and puts it into an R data frame. Also notice up here, I have a percent and R. There are a lot of different things that you can do. You can actually now, I think it's new, you can actually do a percent and pip if you want to run like pip install within your notebook. You can actually change it and use the command line code in here. That's one of the newer features as well. You can run command line code in here. Sorry, it looked like I fell off for a bit. And there is, I think it's a CMD here to do command line. So after I did this, I also had to go and install the Spark R package. And I don't think that's something I've showed you guys yet. So I already have it installed, but if you're going to install like Sparkly R or any notebook or library at all, the easiest way is to come into your cluster. So class cluster is the one I'm using. You can go install new, and you can see here, if you're using PySpark, you're going to be using the PyPy. Cran is R, and a lot of these you will see over and over again. So I already installed it, but you would basically put in Spark R here and install if you wanted to do something new. In Python, for instance, if you wanted to install the stats package, you could do that here as well. And that allows you to upload those packages I believe you can also do custom ones as well with the upload function here. So that allows you to take those packages and it will put them on this cluster only. Also, if you do upload packages and you want to keep that information in there, always click terminate when you shut down your cluster. If you delete it, your packages are gone. So this is how you read in a package in R. So we use the library function. So here we use as data frame. That pulls it down and is using base R to, and this will pull everything to my driver node. That's always something to keep in mind. If you're, unless you do use koalas, if you use pandas, everything will be stored in your driver node. If you use base R, everything will be stored in your driver node. If you want it to be distributed, you have to use PySpark or SparkSQL R or the Java or Scala flavor of that. But what this is doing is pulling it to my driver node. I have this this R data frame, and then I come in and I use the core function. And this is our syntax. Core is the correlation, and I'm just printing out the result, but I'm finding the correlation between migration country R is the data frame. The $ allows you to refer to a specific column, and then I do another column in that data frame. And this is basically an option that you can use complete observations in R. And then I run that, it runs my R code. And yep, there we go. So it ran my R code. Now I can see that the tech migration correlation, so the correlation between the average country migration per 10,000 in 2018, so the overall migration and the tech migration, they're pretty highly correlated at 0.62. And it goes through, the highest one is total migration. And the highest correlation is between science migration and total migration. So that allows you to use R code inside. And real quick, so this SparkSQL R is basically the same thing as PySpark, just for R. So this is helpful to use for individuals who are more of R users. It uses dplyr syntax, and if you're an R user, you'll know what that means. So unlike PySpark, you really don't, it's not as big of a learning curve. I will say that Databricks and the other companies, since PySpark and Scala are the most commonly used, R kind of sits on the wayside and it's more buggy. So I actually flew through that a little bit early. Do you guys have any questions about anything? I am also can go up and cover any of the different functions that you may have missed throughout this notebook. If you want to hear about any of those, I'd be happy to go over it.
I have one question, Kelsey. Mm-hmm. I'm having issues getting my Databricks to run, so I'm not asking you to troubleshoot. Just wanted to know, since I can't run your code right now, is there anything that in the where it tells you the command, and when the oh shoot, can't remember the word now, but when the not the action, the other one, when you're actually doing, say that again.
Actions and transformations.
Yeah, when the transformation happens in like the R code that you're showing, is there anything that shows in the Spark jobs that tells you that it's now an R object, or does it still say PySpark SQL?
Yeah, I don't know. I think it's by virtue you have to have this up there. However, have you installed the package? That might be why.
I'm not even getting down to that point. Yeah. I'm having issues up above for some reason.
Oh, okay.
But I just noticed when you were doing the SQL code that it looked to me like all the SQL data frames still appeared to be the same type as a regular PySpark data frame, and that kind of surprised me because I was expecting them to be, you know, SQL object or something.
So SQL's a little bit different than the R. R, I would say, is definitely because we are actually using these within a PySpark function with SQL. So it's and this is SparkSQL in general, but see, even when we're using it here, it's inside of a PySpark function.
Yeah,
sorry,
no, you're fine.
Yeah, within a PySpark function. This
for what it's worth, your audio hasn't cut out, I don't think, a single time, and I've been able to see you scrolling while you've got that weird connecting sound effect going on. I don't want to speak for anyone else, but it has appeared to me that you've stayed connected the whole time.
Okay, well, that's good to know. So I'll just keep talking next time. But I actually have never looked at that. So that is the really big challenge that we've had with using this at my job, because we ended up with the wrong type of data frame. In a lot of cases, we used the wrong function, and then it wasn't the right type of data frame to use in the R code. If this is something you're interested in, I just actually contacted Databricks and asked for an R expert because I was getting sick of screwing with it. And they gave me a bunch of links that I can then post on my website or put in the PowerPoint that I haven't had a chance to look at them yet, but I'm hoping that it'll help. It goes through full examples. Regarding the transformation versus the action. So you'll see here. Let me go up and look.
Yeah, I understand the difference. I just couldn't remember them when I needed them. That's been happening to me a lot today.
Yeah, so this, you can see that it was a transformation because it doesn't show any jobs. The other one, if you look up here, it shows, since it displayed something, it'll show a job, and that's how we know that it's right here, that it is an action.
Oh, so the R code doesn't even show as a transformation then?
It looked down here, so there was a job.
Because it was just Spark jobs, right?
So there is a job here. So, but I think that that's by virtue of me printing it, not by doing the function. So why not? We can check. So if I do R, so if I take it out of the print statement, I don't know exactly what that'll do. So if I take this, set it to an object, I'll just do test. So here, it was by virtue of printing that I created the transformation. So it works the same way as it did upstream.
Yeah, that's interesting that it's not, it's doing both less and more than I expected.
Have any other questions in general? Oh, there was one other thing that actually came to mind that I meant to mention. So I've been using a really big data set, and it has a lot of joins, a lot of aggregations, probably like 80 of them going through, because every piece of the data is on a different level, and I needed it all to be on the customer level for a model I was doing. So I was seeing a lot of slowness. By the time I got to the end of my code, it was using a ton of memory. But my data set was too big to cache or persist. I went to look into Delta Cache, but the way I actually saw that sped up my code by 3 times is I read the data out to Delta Lake. I wrote it and then I read it back in. because it worked as the same as persist or cache, because it basically broke my code. So it would start when I read it back in, and then it didn't have it in memory and crashed my cluster. So it was kind of like a middle ground there that I found that you wouldn't think writing big data frames back to storage and writing them back would be helpful, but it actually really was. It would not be helpful if I hadn't used Delta Lake, though. That's something I haven't gone over much in my class yet, and if there's interest, I can talk about it. But Delta Lake, if you're going to take storage, it is an absolutely lightning fast, awesome solution.
Yeah, haven't lost you. So.
Yep, and it's even connecting on here.
Yeah, well, that's what I've noticed is I've been seeing the icon the whole time.
Yeah.
So.
Any other questions before we log off?
If nobody else is going to speak up, I don't have another question. I just wanted to say thank you. I haven't had a chance the last couple of classes. This has been really helpful, and actually this weekend I was able to use your first class to get logged into Databricks and start doing some stuff in advance of needing it for work. So that was really helpful. That's
awesome. I'm glad to hear it. One thing that I'm doing in the next class that has been helpful for my coworker, I will be going over how to do machine learning modeling, and it's the hardest thing I've learned in PySpark by far. Like, it's not an easy thing to learn. So I'll probably go over it in many classes, to be perfectly honest. But one of the things that I've really had luck with is having canned code that I've used. And I think I have most of it on my GitHub. Like, I have a full end-to-end modeling, like doing grid search, doing all the different machine learning concepts. That and something like this, feel free to use it to take it into your job and like use this to create new code. I'm absolutely fine with that. If it's going to accelerate you, that's what we always talked about it as an Avanade, it was an accelerator. It made it so that you wouldn't have to go through every step of figuring it out on your own. So happy to give that to you and use it however you'd like. And thank you for the thank you.
Thank you.
Awesome. Yeah, so something I did recently, I actually brought Databricks and we became a Databricks partner since I started my new job. So it's so much faster than the Hadoop options. I can't even tell you. Like, I was watching my sleep tick away when I used the Hadoop option. I was just staring at it and waiting for hours. So Databricks really is 50 times faster than the competitors. All right. Thank you, guys. I appreciate it. Hope this is helpful.
Thank you, Kelsey.
Have a good night.